All right, welcome on in, everybody. Getting started today. So, couple things as we get started here. So, first of all, I want to say that this class is actually doing quite well as far as participation. I would say you're doing better than a typical Math 3 class. I'm seeing a lot more participation. The videos are being watched by most people, almost everyone. The homework is being done by and large by a lot of people. So, so good job. Basically, keep it up. It would be great if we could have a really high pass rate in this class, right? I mean, it would be fantastic if I could just pass everyone in the class. That'd be great. But we gotta earn it by, or you gotta earn it by doing the work. And so far, most people are. So far, most of you are doing great. You're on a great pace to keep things up, and you'll end up with a passing grade in the class, and maybe better, right? Some of you end up with A's and B's and stuff. So that's good. With that said, remember at the beginning of class, we talked about the census date. That census date is approaching. It is somewhere towards the end of this week. I don't remember exactly what date it is. It might be Sunday, but sometimes they move it around on us, so I'm not sure. So what that means is at the end of this week, if I can't make the case that you're on track to pass this class, then I have to drop you, right? That isn't just my decision, right? If it was up to me, I just generally don't drop people. This is a state thing, right? Because the state's giving us funding to run the college. So it's state. The school takes it very seriously. It's in my contract. All this kind of stuff. So it's not me being a mean person. This is literally part of the job. So those of you who are on track and caught up and moving ahead, great. Just keep doing what you're doing. Those few people that have fallen behind, you need to get yourself caught up, or at least where I can make a case that there's a reason why I didn't drop you, because otherwise later on down the road it can come back to me if I didn't drop you before census, but you weren't really doing the work. Then I actually I get a talking to. So I have a little chat with my dean. So I don't really want to do that. So just if you've fallen behind, just spend some time this week getting yourself caught up, and then I don't have to drop anybody, right? That would be great. People probably don't want to be dropped, or if they want to be dropped, they should drop themselves. I'm not looking to drop anybody, but I may have to in a few cases. So this is just kind of a reminder. We're getting to that point. For almost all of you, you don't even have to worry about it. Okay? And this is actually great. So a thing occurred which, again, impresses me about this class and makes me think this is going to be a class that has more success than just a typical class. And that is the communication, right? We are not on ground. It's very easy when we're all in a classroom together for people to come up to me before class and say, I don't understand this topic. I'm confused about what's going on. Can you help me out with this? Or it's also easy to just walk over to the tutoring center if you're on campus. You go, you know what? I have 45 minutes till my next class starts. I'm just going to go hang out in the tutoring center, see if I can get a couple questions answered. It's a lot harder when you're at home, right? And I know there is the Zoom meetings for tutoring, but what the data is showing is that many fewer people are using the Zoom tutoring than would use the in-person tutoring, right? So it's nice that it's there, but it's kind of one of those things. Every time you put more steps between doing something, fewer people are going to do it, right? It's a little harder. However, I sat down this morning. I sat down to kind of go, okay, what should I be going over today? Because as we know, I can't cover all the material, right? So I have to pick and choose the topics that I think need to be talked about. So I sat down and kind of started making decisions, and then I checked my messages from students, and there were 3 separate emails talking about how they were confused about piecewise functions, and they felt like the videos that were available inside Delta Math and that were posted in Canvas were not enough. They weren't really explaining the idea of piecewise functions very well. And I see there's a we got a message early on when the stream went up. Someone else mentioned piecewise functions. So that's good feedback, because then what I decided was, okay, today we should talk about piecewise functions. It's clear to me that there's, this isn't one student who has a question. This is numerous students telling me that they need more information about piecewise functions. Well, then that's obviously what I should cover today, right? So I just want to make sure you understand that works, right? This thing where the handful of you that have let me know, I think I need to spend some more time on piecewise functions, or I could really use some more help with that. That's exactly how this system should work, because then I got the message, let's talk about piecewise functions today. And then hopefully when we're done, those students who asked will be able to finish it. But also, just because I've heard from 4 students say that they're confused about piecewise functions, it's extremely unlikely that there's only 4 students in this class who are confused about piecewise functions. If 4 people are telling me they need to hear about that, that tells me that probably 80% of the class, somewhere between 80 and 100% of the class, need to see more about piecewise functions. So please do that in the future. Otherwise, I'm just guessing on which material to grab since we don't cover everything. I'm just grabbing what I think, well, students sometimes have trouble with this, so then I'm going to go over that a little bit more. So, yeah, and we're seeing, more, another comment about the piecewise functions. So do this in the future. I know some of you may be a little bit behind, so you haven't gotten to the piecewise functions yet, so you don't even know if you're confused on it or not. But it seems to me like, this is really good feedback. The class has basically spoken and said, we need to see piecewise functions. And so I put some examples together so that I can try to explain piecewise functions a little bit more, because I know that is something that in general is confusing. Both the concept of piecewise functions and then the notation for piecewise functions, and then also the graphing for piecewise functions, all 3 of those things confuse students. Okay, so this is a great topic for us to talk about today, and then hopefully everyone can move forward with the homework, and then everyone's happy, right? Everyone's got what they need. Okay, so let's talk about piecewise functions a little bit. So let's go to an example here. So we use functions to try to understand things. So for instance, let's say that you have, let's say you work at a job, right? And you get paid some hourly wage, okay? Well, you're getting paid by the hour, right? So we could calculate what you get paid for a shift that is different lengths, right? Sometimes you might go in for a shift that's 3.5 hours, right? I remember when I was young working jobs, they'd have a lot of shifts that were like short like that, just a few hours, right? It was almost like not even worth going in. But you have like a few shifts, and then you'd have like some longer shifts and stuff like that. So, it would be helpful then to have a function where you put in your hours and it would calculate how many you have, right? Especially when it comes to like and a half. So, most people, depending on what you get paid, maybe you get paid something weird like $15.75, and today you worked a 6.5 hour shift. Well, that's going to be a little harder to calculate because there's a bunch of decimals in it, right? Well, we could just write a function that does that for us. Let's see. There's a question. Okay, so there's another note. Let me make note of this about a future thing to go over. Linear equation in context. Okay, I'll make a note of that, and if there's time, I'll talk about that was just suggested in the chat. There was a direct message to me, so you probably can't see it, but a student asked about another topic. So if we have time after this, I'll jump over to that topic. This is great. Students bring in questions, and then we can answer the exact stuff people want to know. So let's just say let's say you make $15.75 an hour. So we could write a function that says we could use whatever variable we want. I'll use W for wage. That's your wage. Your hourly wage would be, what did I say, $12.75. So we'd have a function based on X. And we'd want to know, what does X mean in this case? Well, X, in the way that we've been discussing, X is hours worked in a day. Okay, so I haven't written out what the whole function is yet. I've just started it. Where am I? Where are we? What's going on? Page went to sleep here for some reason. Okay, so we haven't written our function, but we've defined what the variable is. I find a lot of times students look at a function and they don't even know what the variable is representing. Well, if you don't know what the variable represents, then there's no way that you can make sense of what you're working on. So I've written this down. Always a good idea to write it down. I know this is one of those steps that students like to cut away, but if you're cutting away the understanding of the problem, how can you expect to get through the problem, right? So X is representing the hours worked in a day. So W of X is, what did I say? I said 1575. So that's our wage. X, 1575 times X, right? So that function would represent our wage. Okay, and you go, okay, well, that makes sense. So I could pull up, I could pull up Wolfram Alpha. And we could, just to make this a little bit easier, what if I wanted to say, what if I worked a 7.5-hour shift, right? That's kind of hard to do in our heads. 1575, 7.5-hour shift, I'm not sure. So let's take a look. I could do W of 7.5 would equal, well, that's going to equal 15.75 times 7.5, right? I'm just evaluating. You've done some of this. Whoops, I should put a page break or a line break in there. Okay, so when I'm putting a value into my function, 7.5, so that's my hours worked in a day. How much money do I make for my 7.5-hour shift today? Well, it's going to be 7.5 times 15.7. And just to make it easy, let's put that in Wolfram Alpha. 15.75 times 7.5. Again, please don't use Wolfram Alpha to cheat. Use it to help you understand the material. You'll be better off if you do that. It looks like our answer is 118.125. So it's 1.25 is about an eighth, right? So a little over $118 if that's your wage. So am I going to be able to copy that? Probably not. Nope, that's a link. So let's go 118.125. Where are we? Equals 118.125. Okay, so that's our typical function format, right? And that's really convenient for us. But a lot of times it's insufficient because a lot of times you might be working with the situation where one rule, that's what we have here, right? This function is based on one rule. If we ever want to figure out how much I make in a day, just multiply it by 15.75. But sometimes that's not enough, right? A lot of times when, I remember, working in restaurants and stuff like that, that was one of the big things. The managers never wanted to pay overtime, right? They would send you home, make it miserable for everybody else that still was working and trying to keep the restaurant going, rather than pay one person, an extra $3 or $4 for that hour of work. They would send them home. So, but sometimes you get paid overtime, right? You get paid time and a half or whatever, depending on where you're working. You oftentimes get a higher wage once you go past 8 hours. It's different at different places, but notice this wouldn't work then. Let's say we're talking about a place where once you hit 8 hours, you start making time and a half, right? You make, whoops, did I click something here? Something's happening on my, did I raise my hand? Oh, that was weird. It was doing, my Zoom was doing something weird. Okay, so once you hit 8 hours, you start to make a new wage now. So let's say, like this happened once, like I was waiting tables and it was Father's Day, and I ended up working like a 12-hour shift because we were just slammed the whole day long. Well, once I hit that 8 hours, I started making a higher wage. So what I can't do is come in here and say, well, why don't I just calculate how much I made by doing W of 12, and then I'll just calculate that. Well, this function is insufficient because it doesn't take into account the fact that after 8 hours, I make a higher wage. Okay, so in this case, having just one rule like this doesn't work. It's insufficient. So what I would want to do is create a piecewise function, and our piecewise function, let's see, probably quickest to just copy paste. Let me copy paste this. and we'll bring it down here. So let me just say W of 12 equals a problem, right? This is a problem because it's not going to take into account my overtime. So what we'd want to do then is create a piecewise function, one that has two different rules. One, it'll calculate my wage if I make less than, or if I work less than 8 hours, and then another one that'll calculate once I make more than, when I work more than 8 hours, it'll calculate that extra money that I make. Sorry, I might look distracted. My Zoom is doing something weird. I don't know what's going on with that. I've never seen it doing this before. They keep doing updates to Zoom, and so sometimes it's like there's new features that weren't there before. Okay, so what we're going to do is create a piecewise function, and it'll look a little bit complicated, but here what I'm really trying to get you to do is understand the purpose of a piecewise function, because I know we show students, and a lot of times students are like, I don't really get this thing. I don't really care. Why? I don't think I'm ever going to use a piecewise function, when in reality, you can and should be probably sometimes using piecewise functions. They can be very helpful. So let's put this one in here, and I will go through and change a few things. Let's see. So give me a second to change it. Let's say we've got 1575x, and then we've got for the second one, then we'll have, let's see, this one's going to be, what's 1575 times 8? It's 126. So that means if you work an 8-hour shift, you get $126. So if you work a 12-hour shift, we make $126 on the first 8 hours. So we're just going to calculate that and put that in there as 126. And then now we have to calculate the part that is the overtime part. That's going to be 126 plus, well, let's see. If a lot of places give you time and a half, that means 1.5 times your base for overtime. So if we do that, I'm getting 23.625. Okay, so our overtime rate is $23.625 an hour. So 23.625. But it's not times X, because that would be times our whole shift. It's only for the overtime hours. So I'm going to put in X minus 8. Okay, that way we're subtracting off that first 8 hours because we already took care of that here in the 126. So the key here to realize, not necessarily like this is getting a little complicated, but what I want you to understand is just what is the purpose of this piecewise function. Oops, I should change my cutoffs here. This should be 8. And this one should just say greater than 8. Oops, recompile one more time. One more time. Okay, so we just created a piecewise function that describes our overtime pay, right? And you could see why if you're writing a piece of software, you'd want to be able to do that, because obviously you just want the computer to take the hours someone worked and then calculate their total pay. But also you, as the person making the money, might want to know. So there's two rules now. Remember up here we just had the one rule when you're working a shift? You just plug in the number of hours worked and you got your answer. Well, now when you're at a job where they might want you working overtime, it's a little bit more complicated. Now I have to figure out, am I using the top rule or am I using the bottom rule? Well, how do I know when I'm supposed to use which one? It tells us over here on the right. So this over to the right is the directions about when to use which rule. So if I work 8 or less hours, remember X is the number of hours worked in a day. If I work less than or equal to 8 hours in a day, then I calculate my pay using the top rule. So it's telling me, did you work less than 8 hours? Yeah, I worked a 7.5-hour shift. Okay, then this is how you're going to calculate what you made today, your gross payment for the day, right? Obviously, it doesn't include taxes and all that kind of stuff. Or You say, yeah, I only work 7.5 hours today, so I use this top rule to calculate my shift, but my buddy started earlier and they kept him late. He ended up working a 10-hour shift. So then you work over here. Notice he can't use the top rule because he worked 10 hours. That's not less than or equal to 8. So then we have to look for the rule that fits our friend who worked 10 hours. Oh, down here, 10 hours worked is greater than 8. So that means I'm supposed to use this second rule. So then when we want to calculate what we made today on a 7.5 hour shift, I would use this top rule. Our friend who worked for 10 hours would come down and use this bottom rule. Okay, so that's really all a piecewise function is doing, is it's giving us two different rules which are conditional. They're telling us sometimes you're going to calculate your value this way, and sometimes you're going to calculate your value this other way. Okay, and you just read them you look over on the right to decide which rule to use. Once you've decided the area you care about, then you hone in on which rule you're using, right? So that's how a piecewise function works, and we'll look at graphs of it in a minute as we do this. So let's move to a different example. Also, if there are questions along the way, feel free to ask them. Okay, so let's start with a simpler one here. So what could this be? Well, this is a piecewise function for pricing, right? Depending on what you sell, right? If you work for a company that sells something, a lot of times the more of the product you buy, the cheaper it is, right? We all see this when you go to Vaughn's and you buy one jar of mayonnaise, it's kind of expensive, right? But if you go to Costco or Sam's and you buy like 12 jars of mayo and you just sort of keep them in the garage as you use them, or you buy you probably wouldn't do this at home because you wouldn't want to open them, but like restaurants, sometimes they buy the giant mayo. You'll see sometimes buying the giant mayo from Costco is like a little bit more than the tiny jar at Vaughn's. And you go, how is that? Well, it's because most companies realize that their costs go down if they can get you to buy more, right? It's easier if someone is making a sale buying one jar, just try to get them to buy 4, right? So you can play with the price a little bit. Those of you who are going into business and sales and stuff like that, you're going to learn that if you can sell a higher quantity, you oftentimes can sell those things at a lower price. This happens for consumers, like I say, when we go to Costco or whatever. It also happens to businesses, right? If you need parts for your business and maybe you need a special machine part, and the company that manufactures this says, well, it's kind of expensive for us to set these up. So if you only want 100 of these, we're going to have to charge you a lot. But if you buy 10,000 of these pieces, you'll pay less per piece, right? You'll pay a lower price per piece. So let's say that our company we make some kind of machine part, and other companies buy that part, right? And we say, well, if you're going to buy 9 units or less, right? So let me define it like I did last time. Let's say what X is. X is units purchased. Okay, so X is the number of units being purchased. And then we have our pricing. So, when some company calls and says, hey, we need some of this part that you make, I'll just look it up and say, okay, here's what we're going to charge you per unit if that's how many you want to buy. And sometimes a person may say, well, I was only going to buy 9, but it looks like the price goes down if I buy 10, so maybe I'll just buy 10, right? Sometimes it's in your best interest. So if X is the units purchased, then what this says is when somebody purchases from us 9 or less of these units, they pay $9 a piece, right? That's the price per unit. That's not the total cost. That's the cost per unit, right? We could make a function which was the total cost. But, okay, if someone's going to buy between 10 and 99, we charge them $8. If someone's going to buy more than 100, we charge them $6. We really want people, like if you think about it, think about the transactions for the company. If I have 10 people buying 9 units each, someone has to sit there and write up the invoices and go to billing, and like all those steps get done a bunch of times. If I can just buy a company to say, you know what, we're just going to buy a year's worth, we're going to buy 100 of these units all at once, that's less time that I have to pay my employees to process payments, billing, invoices, all that kind of stuff. So it saves me money as the company. So I say, if you guys will just buy 100 at a time or more, I'm only going to charge you $6 a piece. Okay, so you can see how this function gives us the price per unit depending on how many units were purchased. So if someone purchases 8 units, I would go, okay, 8 is less than 9, so I'm going to use this top rule right here, so $9 a piece. What if someone wants to buy 27 units? I go, okay, well, that's between 10 and 99, so then we're looking at this middle rule. That's $8 per unit. Or someone says, you know what, we need a lot. We're buying 10,000 units. I go, okay, well, then we're going to charge you $6 a piece. Okay, so you look on the right to figure out what X value pertains to the question you want to know about. You might do a problem where they literally just give you an X value. They might say X equals 5. And then you would look up here and go, oh, X equals 5, that's the top one because 5 is less than or equal to 9, right? Or you might have to work a little harder to get that information. It might be hidden in there a little bit more. But this is the idea of a piecewise function, right? And this is now let's take a look at the graph, because I know the graphs can be confusing, because what students tend to do is they just graph the 3 separate functions. Well, we don't want 3 separate functions. We want one function that gives us the whole picture of what we're talking about. So if I jump over to Desmos, this is what I might see when I have a student graph this piecewise function. Is I would get this. They'd say, well, this is y equals 9, this is y equals 8, and this is y equals 6. So isn't that the right thing? No, because notice how this isn't helpful. Let's pick a number like 50. Okay, if I sell 50 units, oops, can't see it on the graph. Let me see if I can bring this up a little. There we go. Okay, let's say I sell 50 units. Okay, so what's my price? Well, there's a green dot, so it's $6, a blue dot, $8, and a red dot, $9. Well, which one is it? Is it $6, $8, or $9? I see the graph for all 3. So this graph doesn't really represent our function because it doesn't convey the same information as our function. So what we have to do is restrict this function to places where it makes sense. Also notice, this is another bad habit, when we're doing a real-world problem, some real-world problems negatives make sense. Some real-world problems negatives don't make sense. For instance, if you're graphing a bank account, there are certain types of accounts that can have a negative balance. Negatives might make sense in that case. In this case, does it make sense that we would sell a negative number of units? No, we can't have someone come in and say, I'm actually going to buy -5 parts from you. We can't do that, right? I mean, you might get into stuff if people start returning things, but you know, that's a discussion for another day. So what we want to do is restrict this graph to the way that makes sense. Well, what this says is that the 9 value only occurs when x is less than or equal to 9. So it should not be going past 9 on our graph. See all this where it's out here? None of that belongs there. So we want to eliminate it. Also, we want to get rid of this negative stuff because that's just silly. No one's coming in and saying, yeah, I'm buying -12 units. So let's make that happen. So what I do is I take this line and I replace it with this shortened version. This line is going from 0 to 9 because those are the values that make sense for this price point of $9, right? So when someone buys up to including 9 units, the cost is $9, and that's what we now see in our graph. Okay? Same with the blue one. So I go, okay, my blue only makes sense when someone buys 10 units up to 99. Okay? So we go, okay, well then let's restrict our graph there. Okay. All right, see, look, this blue one is picking up right where the red one left off. That makes sense. Okay. Okay, good, up to 99. And then now what about this? It's $6 if you buy 100 or more. So once our x value is bigger than or equal to 100, it's 6. So we want to restrict that part of the graph to that part that makes sense. So we do that, and we get this. And all of a sudden, this graph makes more sense because we go back to our question from a moment ago where I say, what's the price if I was to buy 50 units that we manufacture? Oh, well, now it's easy. 50 units, I go up, oh, 8. It's going to be $8 per unit. Okay, see how it's not confusing like the one a minute ago? But it does take some practice to figure out how to figure out, like, we still have the same 3 lines, but we only have portions of those 3 lines. Right? See how they're not overlapping? Once they overlap, the functions don't make sense anymore. They interfere with each other and confuse us. That's back to that whole 2 answers for 1 question for functions, which we don't like. So we can see it's the same x and y values. So if someone says, you know, how many units would it be for 125 units? Okay, you find 125, which would be roughly here. You go up. Oh, looks like it's $6. So we can just read that information right from the graph. Okay, and notice how the lines don't match up. The ends of your different pieces, right? It's piecewise because it's made from a bunch of different pieces of different functions. Those pieces don't have to touch each other. Sometimes that really stresses people out. Oh, is it doing a thing when I show my hands? Did they do something fancy on here? Anyways, my Zoom's being weird, but so sorry, I lost my train of thought because Zoom keeps distracting me. Yep, we broke this down into a way where we can read the graph now. This graph now holds the same information as this function. So this is how we would write it in function notation algebraically as a piecewise function. This is how we would use the graph. It's the same information. So you can calculate it, you know, like we do from a function value where you go, okay, what if I wanted to do, let's do one. So let's say I want to do, what would f of 72 be? Okay, what does that equal to? Okay, so I would take my x value and I'd go 72. Which of these 3 rules does 72 satisfy? Well, 72 is not less than 9. Okay, that's not out. Or that's out. 72 is not greater than 100, so that's out. But 72 is between 10 and 99. Okay, that means I want to use this middle rule. The middle rule says my output is 8. Okay, so 72 equals 8. So we just use that notation. That's like the functional notation form, using it algebraically. And then we can go over to our graph and ask the same question. So if I'm looking at my graph and someone says, what's the price going to be at $72? And go, okay, let's see. 72 should be like right around here. I go up, $8. See how we hit right on the graph? $8. Okay, so you're really using the graphs and especially the picture of the graph. You're using it in the same way we always have. We're answering the same type of questions, but I know it's confusing when there's like different pieces. Sometimes these pieces are going to match up. You'll have 2 pieces that just happen to touch each other, but they don't have to. Like you can have these gaps, that's no problem at all. And it makes sense in this case, right? The prices are probably going to have jumps. They tend to, because a lot of times people, the companies, they want you to have to buy like a little more than you need. They want you to go, well, let's see. If I buy another dozen that we don't need yet, I'll get that price cut. Okay, we'll take an extra dozen, right? So, that's on purpose. Let's see. There's a question here. How did you graph the 10 and 99 one? Oh, so this is a notation. We don't really need this. This is just for Desmos. So there's a specific notation. So I'm still using the same rules of y equals 9, 8, and 6. But you can see if you put in brackets, you can put in a restriction, and it only graphs it over that interval, right? You won't need to do this. You can if you want. So you can see it on screen. You can just copy it from what I'm doing on the YouTube stream if you want to do that. But this notation is a little bit weird because it's for a graphing utility, which is a little different than what you're doing, okay? Also, notice on here we don't have the open and closed dots like you have on some of your homework problems. Remember, the open dot means that it doesn't include that point. The closed dot means that it does. So what would that mean? Well, look at right here. What would happen when I'm at 10 units? Well, by looking at the graph, like if we go over here, it's obvious. Oh, 10 units means we're paying $8 a piece, right? I don't know if I answered the question in chat very well. If I didn't answer it, feel free to clarify the question, and I'll go over it. Over here, I can see, 10 units, that means it's $8 a piece. But it's not really clear on the graph. So sometimes these graphing utilities don't use the dots that you're seeing on the homework. Sometimes they do. Usually there's a way where you can go in and add them, but you have to do it by hand. So in this case, what they would do, there'd be a solid dot. Let me see if I can do this. there'd be a solid dot at 10, 8. See how there's that solid dot there? That lets us know, oh, at this point, this is the value. And you'd probably have an open dot right here. You'd have an open, I don't think I can do that on here, but the open dot would be right here, meaning it's not this value, it is this value. The solid dot means that's a point that you should use. So I know there was at least one question on the email about that, the open dot versus the closed dot. The open dot just means it gets really, really close to 10, but doesn't quite hit it. The value at 10 is this one right here. Okay. So that's how we do that. All right. I have another example. So if anyone has questions on this one before we move on, feel free to ask. No? Okay. Feel free to throw them into chat if you have one. Oh. Show us one in delta. Okay. So let's see if we can do that. So we've got our delta math. Let's look at one. Evaluate functions from, let's see, evaluate piecewise functions graphically. So let's do that one. Okay, let me move this a little bit. All right, evaluate this function graphically. So here we can see we definitely have a piecewise function, right? So this arrow means this dot right here, it doesn't include that value that's right at -3. So at -3, this function is not defined right here. But as soon as you pass -3, so -3.000000001, would be like this point right here. So that's where the line begins. Here we have the solid dot. So right at 5, 5 is included in this graph for an x value. And then it goes down this way. So we are supposed to find f of -4. F of -4. Well, remember this value right here that's inside our function, that's the x value. Okay? That's the x value. So then I go, okay, well, that's an x value. This is my x-axis, right? It even has a reminder over here. That's our x-axis. So here's our x-axis. So I find an x value of -4, and I come over to here. Okay, so when my x is -4, my function value is 6, because that's the y value. That's the height of the line at that point. That's where the point occurs from our graph. So -4 for our x becomes a y value of 6. So when I put that in, I say 6. It's going to say, are you sure? Yes, I'm sure. There we go. I got it right. And then it gives me, and it's showing you, see, here's that line. You find x equals -4, and it intersects the height of 6 right there. Okay? So that's how that one works. Let's see. Yeah. So let's do another one. Let's see. Evaluate piecewise functions. Okay, so let's do one algebraically now. So we've got this. So they want us to find f of 0. So I'm going to give you just a second because I actually want you to practice this, because then you'll get an idea if you got the hang of it or not. Oops, was there a question? Let's see. Yeah, we can do all those. So which rule would you use? Are you supposed to use the top rule, or are you supposed to use the bottom rule? Well, the clue is here. Remember, this is 0. That's our x value. So you'd go over here and you'd say, which of these satisfies my x value? Well, is 0 less than -4, or is 0 greater than 1? Well, 0 is not greater than 1. 0 is, in fact, less than -4. That means I want to use this top rule here. So all you would do is you would take 0, and you would plug it into this equation, or this expression up here. It's an expression, not an equation. I accidentally said equation. We plug the 0 in here for our x value. So that's going to be what? 0 plus 6 is 6. 6 squared is 36. We have -36 plus 2, so our answer should be -34. Submit answer. Yes. Oh, what did I do? What did I do here? Was I trying to do stuff in my head? 0, get 36. Oh, sorry. Oh, yeah, of course. Doesn't make any sense, right? I was not paying attention. I was thinking about what I was saying rather than what I was doing. 0 is not less than -4, right? 0 is in between here. So I missed that they have a gap. Usually in our piecewise functions, we don't have a gap. But actually, in this case, it's neither, right? So it's going to be undefined. Sorry if I threw you guys off. 0 is not in either one of these. So you can't use the rule, right? So undefined That's what happens when I'm doing answers on the fly here. So yeah, 0 is undefined, so we don't have it at all. Okay, so let's try another one since I messed that one up. Let's go to the next one. Next problem. Let's try another one. Okay, f of 2. So I can do one where it's actually defined is what I meant. Okay, 2. 2 is greater than 1. 2 is, we got another undefined one, didn't we? 2 is not less than 1, and 2 is not greater than 4. So another undefined. Let's do another one. Okay, here's one. It says when x is equal to -5, use this specific rule. When x is not equal to 5, use this rule up here. So the only time you'll ever use the bottom rule in this problem is if your x is -5. For any other number, use the top one. Well, that's us, right? 1 is not equal to -5, so I use this top number. So I'm going to plug it in there. So if I put a 1 in there, I get 1 plus 2 is 3. 3 squared is 9. -9. So this should be -1. There we go. Okay. So you're just finding that x value. Let's see if there's another one. Yeah, okay, here's a good one. This is kind of like the one I was looking for. So our x value is 5. So should I use the top rule or the bottom rule? Well, it looks like I should use the bottom rule because 5 is greater than or equal to 5. So I should use the bottom one. So I plug in 5. 6 times 5 is 30. Minus 28 is 2. And I got it. Okay? So that's how they work functionally. So we looked at how to get it from the graph and how to get them functionally. Okay, let's go back to here. What's the other thing? So we've got evaluate piecewise functions graphically. We did that. Piecewise functions. Graphing piecewise functions. Okay, so someone asked about this a moment ago. Okay, so graph the following functions on the axes provided. Okay, so remember, it's just like graphing these two functions that are right here. We're going to graph -5x minus 21 and x minus 9, but we're going to restrict them to the zones in which the x's make sense. So this is telling me that this function only applies when x is less than or equal to -3. So if I think about it, here's where x is -3. That means it's going to be from this line right here and over to the left. So this graph is only going to exist like in this part of the graph over here. And then this bottom one, x minus 9, that's only going to exist where x is greater than 4. So here's where x is greater than 4. So it's this part of the graph over here is the only part that should have x minus 9 listed. So then you're going to go through and you're going to graph those. So hopefully you're comfortable with the with graphing these functions. I'm going to have to, I can't do them all in my head, so I'm going to have to use some scratch paper here because the intercepts are too big. But you're just going to graph that part of the line that makes sense for you. So what I would do, let's do it this way. Yeah, we have enough time for this. Let's go to -5x minus 21. So let's go down to here. So I've got, if my function is, what was it? -5x minus 21, -5x minus 21. And I kind of just want to do the endpoints or see if I can do that. So let's take a look. This rule goes up to when x is x is less than or equal to -3. So it makes sense to me. I'm just going to use that as an endpoint. So I'm going to plug -3 into this function. So let's do it like this. So if I do that, f of -3 would be -5 times -3 minus 21 equals, so let's see, that's going to be 15 minus 21 minus 6. Hopefully I don't make a mistake here because I'm trying to move through this in time to finish. So that gives us the point -3, -6. So if I did this right, we're going to go to, let's see, -3, -6. So we get a point. Oh, it's going to make me do the whole line at once. I'm I'm not sure what our other point is yet. So we're going to start there. So we know one point of -3, -6 if I didn't mess up. If I mess something up, let me know. That way we're not wasting time here. So we have the point -3, -6. Okay, now I need another point. So we could figure out, well, what is it at -5? So if we go f of -5 would be -5 times -5 minus 21. So that's going to be what? Oops, my parentheses got messed up. So that should be 25 minus 21, which should equal 4. And that would give us a point of -5, comma, -5, +4. Is that right? So yeah, that should be right. So now what I'm going to do, I have 2 points, but notice this one here is not my endpoint. I have to go back and fix that. So if I go into my delta math now, I'm going to go -3, -6, and then I'm going to go up to, darn it, trying to keep track of too many things. There was -3, -6, and what was the other point? -5, 4. -5, 4. So you have to just kind of, you could figure out the value at -10, but it might be too high. So it might be that you can't plot that point there. So let's see if I can get this to work. -3, -6, and then we go to -5, +4. So we want to go through that point, but we actually kind of want to keep the line going. So we kind of want it to be looks like it's going to be, oh, and you can put either an open circle or closed circle in the end. Ours would just continue. Let's see. Oh, there we go. There we go. That should work. So we've got our straight line here. Okay, so see how I graphed the one part? So I think, let's try that again. So -3, -6. And I want to go through -5, 4. And it looked like, how did I get that? Yeah, I think the way I did it the first time was the right way. How did I get? Oh, okay, I think I got it. So if we do that, there we go. So that should be right. So if you click the end, it goes through the different options for that endpoint of solid dot, empty dot, or the arrow. Okay. And then you would just go over and do this other part where you have x minus 9 for x greater than 4. So if we're at 4, yeah, so here, yeah, so the question is about will the number next to x can be the slope, and you can use that to find the second point? Yeah, depending on how big your graph is, you can do it that way. So all those skills that you learned previously about lines, those all hold. Those still work here if the thing you're graphing is a line, right? So let's see, for x greater than 4, at -4 or at +4, we would have 4 minus 9 is -5, so we'd have a point here, and then it's going to be going like this. Except this shouldn't be a solid dot, right? Because this is x greater than 4, but this would, oops, that's a 3. I got it in the wrong spot. Let's do it from here. 4, -5. That's where it should be, right there. And it's going up. So using the slope like was suggested, we'll look at our slope is 1. So that means up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on. I'm going to change this to be an arrow. I'm going to change that to be an open circle because it's not x greater than or equal to 4. It's strictly greater than. And doing this on the fly, hopefully I got that all right. Let's see if I didn't mess up the graphing right here or something. Yep, got it. It's easy because the graphs are kind of small. It's easy to be off by like a little bit. Remember a minute ago when I was at -3 on accident? It's real easy to do that. So just double check everything before you do the before you submit it. Okay, so basically you're going to graph the line -5x minus 21, but you're only going to do it for the portion of the graph where x is less than or equal to -3. So you have like an invisible, like they do. Oh, they didn't give us a breakdown like they usually do. So at -3, we would only graph it to the left of that -3 cutoff. Over here, we're only graphing this line where it's greater than 4. And you have to watch whether these are less than or equal to, because you need to know whether you use a solid dot or an open dot. And you need to know about the arrows that are on the endpoints. Okay. And it looks like that does it for time. So hopefully that was helpful to everyone. So you got a better understanding of, hopefully a better conceptual understanding of piecewise functions. And then also we went through and looked at some specific homework problems. Hopefully that was helpful, because that should be all of the piecewise stuff we have for now. Yeah. So we did an example of each type of the piecewise functions that you'll see. Okay, so that was great. Feel free to let me know what you want to see next time, right? If there's stuff that people need to look at, we can take a look at that. Otherwise, I'm going to shut down the YouTube stream. Anyone who wants to stick around and talk to me, I'll talk to you in Zoom, but I do have to move along because I have the office hours on campus today that I'm required to have. So you're welcome to stop by and talk to me in my office hours. And if anyone wants